Good morning. I hope you can see my slides already.
Hello, Marco. We can see you, hear you, and see your slides. I'm going to
Perfect.
give
Excellent.
the room to you. I'm going to give the room to you, and looking forward to hear the nice presentation.
Excellent. Excellent. Thank you very much. So my presentation is going to be about tiny machine learning for water applications. So we heard this morning in the introduction about machine learning, AI, and some of the ethical issues that are posed by AI. So I want to present a kind of alternative model, which is called tiny machine learning, which is about running machine learning on really small devices, such as the one you see in the picture. So the idea is to run machine learning models, narrow machine learning models, so not, kind of general ones like ChatGPT or LLMs, but those are narrow, specialized machine learning models on devices. So you don't need any internet connection. The model is on the device and it runs directly on the microcontroller. So if we want to give a definition, we can say that TinyML is one of the fastest growing fields of machine learning. There's many applications from smartwatches where we have tiny machine learning running to sensors and so on. It's a mix of algorithm, hardware, and software. So there's also the hardware component as we're running these models on microcontrollers. It allows for on-device sensor analytics. So as I said, the model runs on the device, so you don't need any internet connection. It is based on low power consumption. So these devices are usually battery operated. They can live for very long with a really small battery because they're extremely low power. And generally, these systems are always on. So you have an always on machine learning. And again, as we're not sending data on the internet, the ethical and the security and the privacy issues are kind of solved by this solution. It is a mix of machine learning algorithms and of embedded systems. So this is also why TinyML is a bit hard, because usually people have backgrounds either in embedded systems or in machine learning. But here you need to understand both to make sure that things work, fine on these small devices. As you can imagine, these devices have, orders of magnitude less power than normal processors. So on the table on the right, you see that, usually the clock speed is like 10 times slower. The memory is 10,000 times smaller. There's a really limited storage. But again, the power is really limited. So we're talking about microwatts or milliwatts. And the big advantage is that these microcontrollers are extremely cheap because there's so many in the world now. So actually, there's 250 billion of these devices. So the price of one of these chips is well below $1. So now you can have machine learning, algorithm working on a less than $1 kind of device. So usually these devices have kind of three sensors. So application usually fall in these three categories, either using sound or vibration or vision. And if we look at just one application in sound, just to give you an example, we have been working with colleagues from Sudan and from Brazil on an application where we can classify mosquito from the wing beat sound. So by using the sound of the wing beat, we can classify the type of mosquito. And some images on the right, on the spectrogram. And again, don't forget that this happens on the device, which you can buy now on the market for about $10. So a complete, system with the vision and the sound and the accelerometer costs about $10. Another example that has to do with video in this case is about coffee disease detection. So you see there's you can kind of point to a leaf in this case coffee plants, and you can find out if there is a disease, what kind of disease you have, and you can kind of detect the disease in a very early stage. So getting back to application of TinyML in water management, there's few. So one, which I think is kind of interesting, they use TinyML to detect water leakages in pipelines and buildings by, again, using sound, acoustic data, and water flow patterns. This is a application from colleagues from Morocco, and they use CNN models like EfficientNet and MobileNet V2 to detect leaks with a very high accuracy on very basic devices such as the Arduino Nano BLE. In another case, they use an even cheaper device, which is called STM32, again, few dollar device, and they use off-peak demand pattern analysis to understand if there's any leaks. Some pictures from these papers. So they kind of design this test bed where they have buried pipelines and unburied pipelines, and then in the wooden box they have these small devices. And you see on the right there are some scalograms where they show the two cases, known leak and leak, in the case of buried and unburied pipelines. So you see, even from kind of a visual inspection, you can clearly understand when there is the leak and there is no leak. There's the other category of water quality monitoring with these kind of devices. And there's some papers where people use an array of sensors and TinyML models to classify water samples using turbidity and pH levels, saying if the water is good, bad, or ideal. But the kind of interesting thing is that they also take pictures. And so then they use YOLO Tiny, which is a very small version of the YOLO image recognition algorithm, to also assess water quality and to detect if you have any pollutants. And then there's some other application, for example, from Brazil, where they monitor bacteria presence in aquaculture systems. And so this is one of the pictures from one of the papers where they have the pH, the turbidity, and the temperature of the water, but at the same time, they also take pictures and they can detect if there's any pollutant like a plastic bottle. And finally, there's other papers where they study sustainable water usage. So they use the same idea of using audio system to monitor water consumption patterns. So they put this in different rooms in the house, and they can detect excessive usage of water or waste of water, and then they can trigger some alarms based on the flow rate anomalies, so that they can promote a responsible water use. So I think that's all from my side. If you have any question, I would be happy to get back to you. Thanks. Oh, sorry. There's two more slides. So if you want to learn more about TinyML, there's a really good book, which is called a Machine Learning System with TinyML, which is completely open. It's published by Harvard University. Now it would be published by MIT Press. And you can download the whole book. It's completely open, not only the PDF, but also the source. And finally, if you want to learn more about what we did, especially with a focus on developing country, there was an article on Science a couple of months ago about our kind of educational activities in the field of TinyML. Sorry, so those are other two links. And that's all from my side. Thank you.